Today we're going to be looking at lesson 8-3. And so let's get a little bit of the vocabulary out of the way. So an arithmetic series is just a sequence that has addition or subtraction signs in there. So the sum of the terms of the sequence is called a series. That's it. Oops. Let me get my proper pen up here. So that's called a series. The series 3 plus 6 plus 9 plus 12 plus 15 corresponds to this sequence. The only difference between this and this, we have commas here and we have addition signs here. The sum of the sequence or the sum of the series is, you can just add those together on your calculator and you're going to get 45. This is an arithmetic sequence because D is equal to 3. So an infinite series has infinitely many terms. So this particular series here is finite. An infinite series would have a ... and ellipses somewhere in there. So for instance, you might have 2 plus 5 plus 8 plus 11 plus 14 plus ... So that just means that you have an infinite number of items in that sequence. Any series whose terms form an arithmetic sequence, such as this or this, is known as an arithmetic series. Well, that's shocking. So as you can see here, this one right here, if we add 4 to 5 and 4 here and 4 here, 4 here and 4 here, it is an arithmetic series. And this particular one is finite because it has 1, 2, 3, 4, 5, 6. So it has 6 terms. And your D is equal to 4. The D, the fact that it has a common difference, is what tells us that it's arithmetic. Then we're going to have, and this is new for you, is summation notation. You'll also hear me call it sigma notation. And so this thing right here is your sigma. In fact, I'm going to make this bigger so you can see it. So this right here is called a sigma. It's a Greek letter, sigma. And it just means that you're going to add the terms of the sequence. This is your lower bound, this is your upper bound, and this is going to be your explicit rule. And then K is and then it says here the summation notation. I think on yours it says the index is the index, and it should be, is the index of the summation of notation. So don't really get yourself caught up in K's and N's and everything. You're not going to see most of this anyway. This is going to be a number. Well, it could be K, it could be N, it could be I, it could be J. It doesn't matter what variable they use. And this could be 1, 2, 0, but typically it's 1. This is going to be your explicit rule, and this is going to be an actual number. So for instance, this is an example of what that might look like. So notice that this N here is equal to 1. That represents your lower bound, or what's called your lower limit. This 5 is called your upper bound. And this right here is your rule, your explicit rule. So just because they're using N doesn't mean that it's necessarily the same N in your A sub N. However, what it does mean is that we're going to take the first term of the sequence through the 5th term of the sequence. This is not the value of the first term of the sequence. You have to take this lower bound of 1 and plug it into the rule to get the value of that smallest number of the sequence. So for instance, a sub 1 would equal 3 times 1 minus 2. So a sub 1 would equal 1. And it's just a coincidence that the term number of the sequence 1 and the value are the same thing. That's a total coincidence. So look at the fifth term. This means we're going to do 1, 2, 3, 4, 5. So there's 5 terms total. So the fifth term, a sub 5, it's not going to come out to be 5. You've got 3 times 5. So 3 times 5 is 15. 15 minus 2 is 13. So that's the last term in the sequence. All right, so we use the rule to find the values of the first and last term. This is going to help us tell you the number of terms in the sequence. Now, when this value is 1, you can definitely determine just by looking at it that there are 5 items in that sequence. As soon as this number changes, it's harder for some of you to understand how many terms there are in the sequence. So let me just give you a little helpful hint. Take your upper bound. To find n, you're going to take your upper bound, so I'll call that UB, minus your lower bound, and then always add 1. So in our case, our upper bound is 5. Our lower bound is 1. So 5 minus 1 is 4, plus 1 is 5. So in this particular case, n is going to equal 5 terms. And sure enough, there are 5 terms. I will show you, we're going to use that same formula later when n is not 1. It might be 0, it might be 2, it might be 5. All right, so then in summation notation, the least and the greatest integer values of the index n are called limits. So that's that lower bound and upper bound. And remember, they are not the value of that term in the sequence. They are the position of the term in the sequence. So that's that same rule again. So the upper and lower limits, or the upper and lower bounds, are 1 and 5. All right, so then we have 2 formulas. Whoops. Trying to make this smaller. So if I want to find the sum of an arithmetic sequence when the first and last terms are known, so that's important. When the first and last terms are known, we are going to use this formula here. Now, I personally would not use this formula here. It looks really complicated, and really all it's forcing you to do, it looks very similar to this one up here except for what's inside here. And really, if you don't know both the first and last terms, you're going to have to find the explicit rule. And isn't this how you find the explicit rule, except for the fact there's not a 2 there? But this is how you find the explicit rule. So you already know this formula. So I just feel you should derive it instead of memorizing another goofy looking formula. So we're not going to use this formula. So if I were you, I would X through that. I mean, if you want to learn that, be my guest, go right ahead. It's up to you. All right, so let's go ahead and apply some things. So in this particular example, it says the Greek letter sigma is used to indicate a sum. So this is shorthand notation for find the sum of. You're going to use limits, the upper and lower bound, to indicate how many terms you are adding. You are to write the limits below and above this sigma to show the first and last terms of the series. So in this particular one, this is our lower bound and this is our upper bound, and this happens to be the rule. So notice that we don't start with 1 this time. So in order to figure out how many terms are in your sequence, you would have to do 6 minus 2. So your n would equal your upper bound of 6 minus your lower bound of 2 plus 1. So 6 minus 2 is 4, plus 1 is 5 terms. Now if you don't believe me, I'm going to list them out. And this is just position number. 2, 3, 4, 5, and 6. Those are the position numbers, not the values of the terms in our sequence. But as you can see that there are 5 of them. So this works. Now this is not an arithmetic sequence, so we cannot use the previous rule in order to find that. But if I were to actually plug these values in, and I'm going to plug in 2, 3, 4, 5, and 6, and I'm going to get the sequence. So if I take 2 and square it, I get 4. If I take 3 and square it, I get 9. 4 squared is 16, 5 squared is 25, and 6 squared is 36. Now all I have to do is add those. So plus, 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 plus equals, and if you use your calculator, it will add to 90. So in this particular case, I could not use the previous formula because this is not an arithmetic series. Notice that these are not being increased by the same number. So from here to here it's 5, from here to here it's 7, from here to here it's 9. So it's not the same number every time. So for example 1, it says, and a little bit of this is cut off, but you can still read it. Well, here, I'll move it over a smidge. There we go. So it says, find the sum of the first 100 natural numbers. So in order to use the sum formula, so let's write it out again. Oops. All right, so in order to use our sum formula, we need to have sum S sub n is equal to n divided by 2 times a sub 1 plus a sub n. A sub n is the last term. So I need n, the number of items in our sequence. I need the first term and the last term. So the sum of the first 100 natural numbers. All right, let's gather some information. N is going to have to be 100 because I'm adding the first 100. So it's implied that there are 100. A sub 1, the first natural number, is 1. A sub 100, that's the last term, is going to be 100. So there's not a lot of stuff we have to figure out on this. We just have to plug it into the formula. So S sub 100 is equal to 100 divided by 2 times 1 plus 100. So this is going to equal 50 times 101, which is equal to 5,050. All right, and then example 2. Make it a little bit smaller because I need all the information. So sorry. Okay. So for example 2, you were to find the sum of the first 15, so that tells you right there that n is equal to 15 of the arithmetic series, so you should know it's arithmetic, and here it is. So all I need to know, and the more times that you write your formula, the more likely you are to memorize it. So S sub n is equal to n over 2 times a sub 1 plus a sub n. So I need to know the first term and the last term. Well, I know that a sub 1 is 2 because that's the first term of the series. What I don't know is the 15th term. I don't know a sub 15. Now, could I find the common difference? The common difference here is 3. Could I just keep adding 3 and get to the 15th term? Of course. But there's an alternative method. I could actually find my explicit rule. All I need to do is plug in some things that I know. So let's go ahead and find the explicit rule. So down here, I'm going to do a sub n is equal to, our first term is 15. Oh, 15. Our first term is 2. So our first term is 2 plus n minus 1 times our common difference of 3. So that gives us 2 plus 3n minus 3, which is 3n minus 1. So that's our a sub n. And then we can find the 15th term by plugging in 15 in for n. And that's going to give us 3 times 15 is 45, minus 1 is 44. So our 15th term is 44. So then we're going to plug those values into the summation formula above. So n is 15. And so our first term is 2 and our last term is 44. So 15 divided by 2 times 46, and then that's going to give you an answer of 345. All right, let's look at example 3. So for example 3, make it a smidge bit bigger. You were to find the sum of the finite arithmetic series, so you're told it's arithmetic. You have the first term and the last term, which is great, because remember in this formula, a sub n equals n over 2 times a sub 1 plus a sub n. You need the first term and the last term, so we have those. The problem is we don't know how many terms are in this series. They don't tell us. We know that there's a whole bunch in between here. Now, could you write them all out and then count them up and figure out? Of course. But an alternative method is to take, you're going to have to find your explicit rule. So step 1, find your explicit rule. So I'm going to use a sub n is equal to a sub 1 plus n minus 1 times d. So I'm going to plug in all of my values. I'm going to plug in 99 in for a sub n because the only unknown I'm going to have is my n. My a sub 1 I'm going to plug in here, which is 4 plus n minus 1 times my d. Now that we can tell, our common difference from 4 to 9 is add 5, add 5, add 5, add 5. So your common difference is 5. So let's solve for n. So I have 99 equals 4 plus 5 times n is 5n, 5 times negative 1 is negative 5. So I have 99 equals 5n minus 1. I combine the 4 and the negative 5. Add 1 to both sides. I get 100 equals 5n. Divide both sides by 5. I get n is equal to 20. So there are 20 terms. All right, then the other thing we needed was a sub 1. So this is going to be a sub 1, and then this is our a sub n, which is our 20th term. So we're ready to throw that into our summation formula. So the sum of 20 terms is equal to 20 divided by 2 times the first term is 4 and the last term is 99. So we get 20 divided by 2 is 10 times 103, which is 1030. All right, so example 4, this time you're to find the sum of the series. This already indicates a sum anyway, but it's just the sum of the series. And so they're using k. This is we're going from the first term to the 13th. So there are 13 terms in this sequence. 13 minus 1 is 12, plus 1 is 13. So I know for a fact that n is 13. Then we need to find a sub 1. So a sub 1 is equal to, we can see the rule here. We're going to plug in 1 for k, and we get 9. And then we want a sub 13, so we're going to plug that into the rule as well. And then if we work that out, 4 times 13 plus 5 is 57. So now we have everything we need. So So we're taking the sum of 13 terms. So that's equal to 13 divided by 2 times our first term we found out was 9, and our last term is 57. So we get 13 over 2 times 66. And then we end up with a final answer of 2 goes into 66 33 times, and 33 times 13 is 429. All right, so now you're going to write your own sigma notation. So when you do that, we're going to start with our sigma. You must, and you can assume that this is the first term, second term, third term, fourth term, fifth term. So we are going from n equals 1 for a lower bound to a fifth term for your upper bound. Now you've got to come up with your rule. So I know that d here is equal to 3 because each number is increasing by 3. So to write out our rule down below, a sub n is equal to, our first term is 3, plus n minus 1 times our common difference is 3. So we get 3 plus 3n minus 3, and that equals 3n because these two are going to cancel. And so I know that my rule here is going to be 3n. And that's it. You just had to write the sigma notation. You did not actually have to find the sum. So then you try that for b. I know that there's fractions, but you can find out, actually b is a little bit difficult. Maybe I'll do that with you because b technically is not arithmetic. If you notice, if you go from 1/2 to 2/3, you are increasing by, what is that? Let's see, 2/3 minus 1/2 is equal to 4 minus 3 over 6, which is 1/6. And when you do the next terms, let's do 3/4 minus 2/3. You get 9 minus 8 over 12, so it's 1/12. So notice that you don't have a common difference. So this isn't actually an arithmetic sequence, but you can still write sigma notation. So this is our first term, second, third, fourth, fifth, and sixth. So n is going to equal 1 for our first term, and we're going to go to the sixth term. Now to find the rule, if you compare, look at the numerator separately from the denominator. If you compare the numerator to our position number, aren't they identical? These are identical. So to find the numerator here, I just have to know that it's n. So the 15th term, my numerator is going to be 15. Now look at the denominator and compare the denominator to this position number in the sequence. How do we go from 1 to 2? From 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7. Aren't we adding 1 each time? So it's n, because this represents n. This is our n. And so it's just n plus 1. And so that's our rule. That's it. All right. Then for our last bit, you are going to write your summation notation, and you know that you have a sub 1 is 2, so you know your first term, and you know your common difference, and you know you have 20 terms. So let's write our summation notation. So I'm going to go from n equals 1 to 20 because I have 20 terms. And then I have to find my common rule. So a sub n is equal to, they already told me my first term was 2 plus n minus 1 times, and my common difference, they said, was 5. So I get 2 plus 5n minus 5, and to simplify, I get 5n minus 3. All right, so then you are to find the sum of that series. So there's 20 terms in it, right? So you go ahead and do this on your own, pause the video, and then come check your answers. So our first term is 2. We do have to find the 20th term. So a sub 20, I'm going to put it through the rule. Is 97. So 97 goes up here. So you get 990. All right, so then I want you to do example 7 on your own. Pause the video and then check your work and see if you get it correct. Okay, so for number 7, you should be doing your own work and checking it. So here are your answers. If there are 30, I want to do this in blue. If there are 30 logs in the first row and then 29 in the second, 28 and so on until you reach 1 on the top layer, then we want to find the sum of that. So to use our formula, we already know all the information. We know that n is 30 because if you go from 30 to 1, there has to be 30 items in that sequence. We know that a sub 1 is 30 and a sub 1 is 1 because we end up with 1 on the top layer. So we really don't have to gather any information. So we have s sub 30 is equal to 30 divided by 2. And then our a sub 1 is 30 and our a sub n is 1. And so you end up with 15 times 31, which gives you it gives you 465 logs. Now, I went ahead and left this in here, but you can actually use a calculator to find the sum of a series. If you go into the math menu on your calculator and scroll down to 0, you will get this summation where it will allow you, it'll give you a box here, and a box here. And it'll allow you to put all of these items in there. So it'll end up showing up like this. And there'll be a box here, a box here, and a box here, where you have to actually put, and I would use x, not k. So I would put x minus 1 here, you got to put the 12 here, and then 6x minus 3 here, and you can actually come up with your answer of 432. And you're like, well, why can't I do this all the time? Because you're not always going to be attached to your calculator, and not all calculators, in all honesty, have this on them. So it's just a convenient feature, and there it is for you. So good luck with your homework. Make sure that unless you're told you can use your calculator, that you're showing it algebraically.